Hello, good afternoon. I'm Isaac Brodsky, CTO and co-founder of Fused and also maintainer of the H3 open source project. And welcome to my talk about blazing fast geospatial SQL and DuckDB is by combining H3 with DuckDB. And if you're not sure what those things are, don't worry, I'm going to get into that in just a moment. So H3 is an open source hierarchical hexagonal grid system that was developed at Uber. And Uber developed this for analyzing marketplace supply and demand data. And it was released as open source around 2017, and it's been seeing uptake in a lot of different use cases since then in logistics and weather and agriculture and across many different fields. So you might think, well, what's special about a grid system, and why should I care about that? I think that we all know that geospatial analytics are complicated. I don't think that we'd be at this conference if that weren't the case. There's a lot of different types of geospatial data. There's raster data, there's vector data, there's all sorts of different projections and coordinate systems and ways of partitioning data. And the thing that H3 helps with is, I think, a couple of kind of key points that you want to get from it. One is that it gets this data into a form which is computationally very easy to work with. It gets it into these 64-bit integers that we can do bitwise arithmetic on, we can do partitioning on and queries on. And the other is that it gets it into this into a common spatial and computational index, a common form that can be joined between different data sets. So it helps with bringing different data sets together because it forces them into a common language, a common way that they can be joined. DuckDB is an open source, in-process analytical database engine. It's seen a great deal of uptake over the last, I would say, a few years. It had its version 1 release, I think it was this past year, and its version 1.1 release actually just yesterday. So some of my slides, I'm going to be pointing out some updates that have happened in the last in the last day of DuckDB news, but I prepared them with the previous version because that was what was stable at the time. DuckDB, for those of us who know and love SQLite, the way that I like to explain it is as SQLite for analytics. So it has columnar execution, as vectorized execution. It brings in a lot of advances in how computing can happen in a single node way. So it's not a distributed system, it's a single node system. And it's been seeing a lot more adoption recently as there's been a focus on high performance, high efficiency computation that also doesn't have the kind of overhead of a distributed system that would come in and add operational challenge and infrastructure challenge. If we think about how you can use DuckDB, you can use DuckDB as just a standalone SQL engine. I'm going to show that in my presentation just kind of for demo purposes. But usually the way that you'd use DuckDB is embedded into another application that you're developing. So that might be a web application, like I mentioned at the bottom, which could be happening via WebAssembly. There's also a DuckDB shell. You can find that at shell.duckdb.org. Or it could be embedded in a host application that could be running like on a back end, in a desktop, kind of wherever you want it to be. And this is a key advantage of DuckDB is that it sits wherever that application sits. If we think about where you might find DuckDB in the stack, I want to show this just as a visual aid, not as kind of a prescriptive idea of where you would put DuckDB. But DuckDB is really great at reading Parquet files, reading cloud-optimized data files. So you might have a data lake like S3 or Google Cloud Storage, and then you might have a back-end process running in, let's say, AWS Lambda or Cloudflare workers or another, or in Kubernetes or whatever it is, that's closer to that data, that's providing maybe some filtering and some aggregation on it. And then they could have a DuckDB instance on the front end, which is receiving that and allowing the user in real time to make queries on this data and to explore it, filter it, pivot it, whatever it is they want to do. Again, this is not prescriptive. This is just some ways that you could use it. So if you have open data that you can put on an open cloud storage bucket, you might not need to have any kind of server process there at all. That could be done via a web browser, just directly querying those data files. And similarly, you might not want to have a complicated front-end application. Maybe you just have a server process providing data. It's also possible to have DuckDB involved in like the ETL process, but I think that that's kind of less common, so I didn't include it. So I promised that I wanted to show some quick start of how to do some queries in DuckDB. For that, I'm going to be showing the Overture places data set. And Overture, for those of you who haven't heard of it yet, well, you're in luck because there's a talk about it tomorrow at 11:30. I think that talk is in this room, if I remember right, but you can double check that on the agenda. Yeah, Overture is kind of analytical OSM. So a lot of places data, buildings data, administrative boundaries data, data about road networks and infrastructure networks that have been prepared by this foundation in GeoParquet files. So they're in cloud optimized data files, and they're kind of ready for analysis and ready for use in that sense. In this example, I took the places data, which is points of interest. So you can think of that as like restaurants and hotels and so on and so on. And I loaded that onto my laptop. I used the DuckDB shell to do this. This did have to transfer maybe a couple of gigabytes of data, but it happens pretty quickly. And then I'm able to start exploring this data set. So I just selected my data. I just loaded my Parquet files, and then I just selected a few sample places. And I want to take a quick detour into some stuff about Overture here because something looks kind of familiar if you look at this ID column, or it looks familiar to me. And the reason it looks familiar to me is because the first half of that ID column is actually already an H3 index. And I can tell this because of the bit structure of the H3 index, and it's kind of a unique signature. And so I'm able to see that that is actually an H3 index. If I take that and I plot it on the H3 website, I can actually double check. Unfortunately, you can't really see the label on the map here, but hopefully you'll trust me that it says that it is in fact the POI that the Overture Maps data set says it is. So there is actually already H3 in this data set to some extent. But how I'm mostly going to be using H3 in this talk is via the H3 DuckDB extension. And that's kind of one of the key points of my talk is there is this extension ecosystem for DuckDB. And DuckDB extensions are quite powerful. So there's an H3 extension, there's a spatial extension, there's extensions for like, I believe, date, time, localization type of operations for different network protocols, file types, and so on and so on. And extensions are really powerful in DuckDB because they're written in C++. They're written with the same level of power as the underlying database engine. So we've already talked about this. This database engine is really interesting because it has all this power to it, and then the extensions are able to take advantage of that as well. This is unlike some cloud vendors or other proprietary systems where you might be asked to do this in a sandbox. With DuckDB, because it's open source, it's running on the same process, you can make it as powerful as you want. So this is kind of a quick start with the H3 DuckDB extension. You go to the GitHub repo, or you can just write in your DuckDB shell, install H3 from community, ;load H3. This is not standard SQL. This is something that DuckDB added on top of it with this concept of a community channel. And this was kind of an innovation that DuckDB added in order to distribute extensions. Previously, it was kind of complicated to get extensions running. Now you can just go to this community channel and download your extension from there. H3 was one of the first extensions that we were mentioned in the blog post here as being part of that project. So when I was building the H3 DuckDB bindings, I made some slightly different decisions than some of the other bindings of H3. One of them was to use the integer form of the H3 index. So you've seen before that there was that 8FF yada yada number, and that is of course a 64-bit integer. There's different representations of that you could use. You could represent it as string. That was done in some early versions of H3 bindings for portability reasons. In this case, because we're focused on fast, we're focused on performance, I chose to go with the integer form. And again, to kind of reiterate, DuckDB is a very powerful database engine, and so it's going to automatically be parallelizing my queries for me as we go. So I promised, fast SQL. I promised, doing some kind of operation pretty quickly. So I want to get into that, and I want to deliver on that promise. So I started with a data set that a friend and colleague of mine, Nick Rubinowitz, had pointed me to, which is the Natura 2000 biodiversity areas, which are a set of areas in Europe that are distributed as a geopackage or shapefile. This is distributed as like roughly a gigabyte geopackage. I converted that to GeoParquet, and I still got about a roughly 1 gigabyte file with just a very naive conversion, which is kind of difficult to work with. If I want to do that in like a serverless process, it's going to be kind of a pain to work with. I'm going to have to transfer a gigabyte of data to wherever that code is running, either on a Lambda or browser or wherever it may be, and it's going to have to load it, do whatever operation over potentially a very large file, and then finally get done. So instead, what I did was I used DuckDB and the H3 extension to index this into the H3 grid system. I used, I believe it was resolution 9 here, which is roughly city block level. So I'm trading off a little bit of the precision of the data set. And you can see that the Parquet file size, I also dropped a few columns, by the way, from the Parquet file, but the Parquet file size drops tremendously. So it goes from gigabyte level to tens of megabytes. And if I use some other algorithms in the H3 library called compact, I can get that down even to single-digit megabytes by using a more, well, as the name suggests, compact representation of the geometries in the H3 index. And the upshot of this is that I can do very fast joins now between this Overture data that we talked about a moment ago and these Natura areas. So here I'm using some of my own tooling in Fused to write a function on the left, which is essentially just a regular Python function, which Fused is then running for me on a backend instance in real time and producing the map on the right. So this function, as we see here, I have my join with my Overture data and my biodiversity areas. On the right, those yellow hexagons are the areas where there are buildings that are within a certain distance, a certain radius of those biodiversity areas. Most of those are not intersecting with the area, but I think that there's one in the middle there, which it looks like it probably is a building in that area. I can, of course, change my K, change my distance number of what radius that I want to have, and recompute this map. And I can recompute this very easily. I can even recompute it for, K equals 10 and 20 and so on and so on. I don't want to get too far into the details of how the Fused interface works and things like that, but I do want to point out the timer at the bottom right, which is showing in this example that this is coming in real time, essentially. So as I'm moving around the map or as I'm changing these K numbers, this map is generating for me entirely fresh. And I actually have a video example of this, which I will try to show quickly. And this one, I made a bit of an improvement to also show what the area looks like itself. And I can see that these tiles are going to update in just a couple seconds, as we saw in the timer. So again, I'm able to do this kind of operation in real time thanks to running it in DuckDB. Go back here. And indeed, I can do this entire operation. You saw before that I had like a little bit of Python code and then my SQL. I can do it pretty much of this that I want in DuckDB. I was going back and forth between them, kind of more for my own comfort reasons. There's some operations where it was easier for me to do it in Python than it was to express it in SQL. So this is also kind of an important thing to remember about DuckDB, because it's embedded in your own function, in your own application. You can make trade-offs about where you want that boundary to be. There can sometimes be performance implications to this. So if you're transferring a lot of data to and from it, then you might wind up with some inefficiency there. But for the most part, you can kind of choose which tool you're comfortable with, or which tool is right for the job based off performance, and use the right tool for the right job. I can return kind of briefly to Overture places and just give a few more examples of how to do some things in H3 and in DuckDB. This is actually one of the examples of the slides that is a little bit different now for DuckDB 1.1. And this one I had to do a little bit of like wrangling of the geometry column. That's something that they've improved tremendously in the latest release. And so I think the Overture example SQL queries are going to be updated to account for that very shortly. DuckDB has much better support for GeoParquet now, so I don't need to do that. Anyways, the H3 operation that I wanted to mention here is H3 lat long to cell, which is kind of one of the key indexing operations, which is taking coordinates and getting this H3 cell. If we compare the H3 column, we can see that we got somewhere which approximately matches what the Overture ID looks like. So that's also kind of a good quality control measure. We did something when the output looks plausible, so that's good. I can also index at a lower resolution. And the reason that I want to index at a lower resolution is to be able to do aggregation instead. I think this query took maybe a minute or two on my laptop and was running over the entire Overture places data set. And what I did here was I took all the places, I aggregated them by these kind of coarser hexagonal cells, and I took what are the top cells over the entire world, or over this entire data set's coverage. And if I check where these are, I can see that they're, looks like in Vietnam and Brazil and in Taiwan, which makes sense because these are huge metropolitan areas, and so it would make sense that they have a high density of places in Overture. These maps, incidentally, are not to scale. So I want to round out my talk by, again, kind of comparing H3 and DuckDB to, or running H3 through DuckDB to some other options that you have. One is to running it on kind of proprietary big data systems. This is a situation which has kind of improved quite a bit recently, but is still not fully there, unfortunately. And this is that most of these systems require that H3 be run through some kind of like isolated sandbox environment. And this generally involves running H3 transpiled to JavaScript inside of a JavaScript VM, which, as you can imagine, was something that was developed originally more for portability and for use in the browser rather than for use in like a big data system. And so these systems find it harder to take advantage of the integer form of the H3 ID, which is a big part of why I got such storage savings earlier in my presentation. And so obviously avoiding inefficient encodings and avoiding inefficient ways of executing the code is fairly important. This is improving a little bit, but you have to check what did the vendor actually do in order to know how is it going to perform. Versus Python, again, we showed the ability to go back and forth from Python and DuckDB thanks to DuckDB's Python wrapper. Python and DuckDB, if you're doing just a few operations on H3 indexes, are probably going to have very similar performance because they're both running machine code, but there will be differences. One is that Python traditionally has found it very difficult to take advantage of multiple CPU cores. This is something which, again, is kind of improving, but you have to keep fairly up to date on what's happening in Python and what's the appropriate way of vectorizing these operations and looping these operations. So it kind of becomes more complicated to keep up with how to do things there. Also, at the moment, H3 DuckDB, I believe, has a more complete set of bindings of the H3 API because the H3 Python binding has been in beta for kind of a while. Hopefully, that'll release a final version for relatively soon, but as of yet, H3 DuckDB has a few extra functions that are not available there yet. And as I mentioned, obviously, when you're comparing any of these systems, kind of your own comfort with SQL or Python or R or any other language, of course, is an important consideration. And if you are familiar with one data stack or another, that can play an important role in this. So I want to just kind of reiterate a few of my points. H3 and DuckDB can be a faster alternative to some of the other bindings of the H3 API. The H3 DuckDB and really DuckDB itself are set up for performance. That's one of the key advantages of them. And so if you're considering using these systems, that might be an additional impetus to do so, to check them out. And also algorithm change can have a really significant effect on performance. Part of the reason that I was able to get the results that I did in this presentation were thanks to the fact of just changing the data from this kind of vector format into an indexed format that I know how to do different optimizations on top of. And I actually want to show one other video real quick that I did include earlier to, again, kind of reiterate how fast this kind of operation can go. Here I'm loading in data from a New York City taxi cab data set, and this has, I think, somewhere on the order of more than 100 million points as part of it. I'm going to rerun that animation here. And you can see I'm also bringing in some other data at the same time. The data that's coming in from the taxi cab data, that heat map data, that's the one that's being loaded through DuckDB. And you can see that's actually coming in significantly faster than the other processes that I'm doing here. So even though I'm getting an excerpt from a very large data set, I'm able to do that very efficiently. And that can be a powerful part of my analytics pipeline. So that is my presentation. You can find me at the usual places online, so LinkedIn, Twitter, GitHub, and so on. You can also email me. My company Fused is hiring, so please reach out. And we also have a webinar coming up if you want to join that as well, where you can learn about what some of our customers are doing with Fused. Thank you. Okay. And I believe we have a few minutes for questions if anybody wants to ask. And obviously, I'll be here, for the rest of the conference as well.
I'm not super well worked database. I know that we're currently getting left to our submitting Postgres, USDA. What would be your selling points to do this set?
So the question was, somebody who's using Postgres or PostGIS, why would you want to consider a tech stack like this? I think that there's maybe a few things that I would add as selling points. One is that in terms of the operational complexity, it can be kind of easier to manage. So Postgres, one of the challenges of it is you need to have some Postgres server, and it needs to be like a long-running VM or hardware server or something like this. And if you have the expertise to manage that, at the time and energy to manage that, that's fine. If you don't have the expertise to manage that, or that becomes kind of a drain on resources to deal with making sure that database server is has disk space and is okay, then something like this becomes really advantageous because you can use blob stores like S3 in kind of a kind of fire and forget way. If you just put the data there and you kind of forget about it and then get charged, I guess, by AWS to host the data for a while. But that hosting charge is hopefully relatively low compared to what you'd be spending on a database server. The other reason, apart from the kind of operational trade-offs of using something like that kind of cloud data stack versus Postgres, is performance reasons. So Postgres is going to be much, much faster for, let's say, edits on the data. So if you're like making transactional changes to rows, Postgres is going to be really great for that because it is a online transactional database. If you're asking analytic questions of this, then DuckDB or another analytic database is probably going to be much more performant for this because it's focused on columnar execution, it's focused on vectorized execution. There's much more performance focus. So, okay, I think we're at time. So again, thank you all for coming.